Hi, welcome back. Today's episode is about working with dates, how to handle different variables containing date, how to extract week of the days, year, month, transforming, merging dates into a single column. What is this library lubridate? What is the library zoo? And how to work with some time series to extract month and dates. This is all we're going to talk about today. Variables involving dates sometimes are a little bit confusing or problematic. That's why we're going to start talking about date and using the library lubridate for handling this kind of solving our problems with dates. First of all, I want to show you a variable named xd that we're gonna change string, in this case 2012 July 27th, to a date. We have used as.Date to convert this string to a variable date or a data type date. Okay, then you can see that R is going to handle this object or this data as date. You can see it right here. So it's different than saying, for example, integer or float, right? So it's a different data type. Okay, and if we want to convert back this date to string using just the function str, as you can see here, date, and it's this format we used. There are so many other functions we can use for extracting information from date types, or for example here, weekdays. Okay, with which week of the day we have so far here. So if you want to investigate, for example, a day in one of your variables, you say taking Mondays, Fridays only, so you can use this function weekdays that is coming from R. Here we're gonna add, if it's possible, of course we will test now, if it's possible to add 7 days. Let's see. It did it. That means that if we use back this function and we add 7 days, it should give us the same answer. That means that 1 week later, right? And what can we do if we want to create a sequence of values? Then we have here July 27th. If we add 6 days, right? I start using 0. That way we're gonna start with the same date. It's different than saying this. Okay, you keep an eye on this, because if you start the sequence with 1, it's not gonna start in the same day, right, in 27th. So that's why I'm gonna start the sequence with 0 and then add 6 days more, keeping my original date, my original day. Let's see. As you can see, my original day, and then I add 6 days more. That means at the end I have 7 dates here. Okay, and as you can see, because we're handling a date class, R can pass from July to August. Can you see here? July has 31 days, and next date should be August 1st. Okay. So anyway, we successfully changed our calendar. Okay, and here we using the same function weekdays, we can extract information. You see, Friday, Saturday, Sunday, Monday to Thursday. Okay, start date, let's start with January 1st 2012, and I want to show you how to create a longer sequence of the dates using the function sequence as my starting date. And I'm saying, okay, I want to create some sequence of dates by 2 months. This is how I want to change. Length 6. That means that we're gonna change by month, not by days, nothing else but month. And let's see the result of this. Okay, what is gonna be the final result? Let's see. As you can see, by using by, my step is 2 months. That means that the first one is January 1st, the second one is March 1st, and so on, as you can see. And 6. Okay, it takes the original date, the start date, and plus 6 days more. Okay. Okay, if we have a function called weekdays, there must be one function called month to extract the information. So let's see the different months in our sequence XM. January, March, May, July, September, and November. Okay. The same quarters, of course. Let's see which information. So with this, it's going to help us, for example, for financial problems. If we want to talk about in which quarter of the year or that in our financial year we are, or information is, if we want to group it, then you can see quarter one, because January and March belong to the first quarter, and May belongs to the second quarter, and so on. Okay, these functions are very useful. Okay, the next is, as you saw, I defined my date first as a string, and then I use the function as.Date, following this format: year, month, and day. But not always we will have this format. So what happens if I have this format here? For example, not separating my date, my information, my variable, by any other symbol like this one, right? So how to handle this, right? If there is any warning, R is telling us, okay, I cannot handle this as a date, so we should convert this. We have to transform it. And let's see. X is a string, of course, character, as you can see, and we can ask to transform this string as before to a date. Let's see, and check it out. Check out this error. It's not possible. Why is it not possible? Of course, because the format of our variable, our value in this case, is not following the same than this previous example. Okay, so what we should do, right? Okay, we're gonna use for that the library lubridate. Okay, and then we're gonna start using some function from lubridate. Okay, for example here, lubridate, and we are gonna tell to this function which value or which number is our year, our month, and our date. Let's see what it does. As you can see, it transformed it, right? Following the format I wanted to. Identically, if we want to transform this value, this date, to a data frame, let's see if I remove this part here, list. Okay, using the list, and let's see my date. Okay, in this way I can create some, this is for creating a variable, well, multiple variables. Okay, create multiple variables in a data frame, as you saw. Okay, and then we can transform back this. Suppose you have this data frame and you want to convert, or you want to merge all my 3 variables, year, month, and day, to a single column, and then we're gonna merge to a single column. Why? Because I'm gonna tell, okay, from my day, use year, and the month, of course. Let's see. All right, there it is. So we could have 3 different columns or 2 different columns, let's see in this case, and transform it to a single column if we want, for example, to plot a time series or analyze a time series. Okay. Let's see. Let's see how to handle some date. Let's say, for example, today. It's a function coming from R. Today is March 7th. Now is for time. You can see ymd. As you can see, the function we're going to use is from lubridate. Okay, it's here. Remember what we had about x, right? This was x, a string. Okay, now the x didn't have any format, but I want to convert this to saying, okay, this string you have here, 2020 0101, that's what I want, right? But it's not separated by any comma or any slash or dash line or whatever. And then I want this to convert it to some format like this, right? Okay, this is my idea. This is what I want to send, and then using this function ymd from lubridate, y stands for year and for month, indeed for day. Let's see. It is able to do it, right? The function mymd is able to transforming this string without any format to the desired format. Let's see in a different format. This is capable of doing this, right? Because as.Date, as we saw before, it did it. It transformed this to a date. Let's see if this same function, right, can do the same. Let's see. Then it can do it as well as.Date, right? So myd is has more power, or for more power transforming for handling strings. Let's see. Okay, so with this function in ymd, I can transform it back to x, and now x is a double, okay, but belonging to the class date. Okay, let's see here. Any other format? Here you can see, okay, this is 1101. What it should be? Okay, I'm trying to tell you here the format of my variable is month, day, and year. So lubridate is capable of transforming this string to the desired format: month, day, and year. Let's see. Okay, there it is. It transformed our desired variable, or value in this case, to a new format, and it converts the string to date. Okay, let's see here what it does. ymd, when I have a string vector, the first value of this vector is a date, but Harry is not a date, of course. And then let's see what is the message. Okay, it failed, right? You see here, it's important to see that even ymd was not capable of changing Harry to a date. Is parse the error, right? It changed it to NA. Okay, I couldn't change it, but I warned you about this, and then I'm gonna put an NA, a null value. Okay, let's see. It's this one. How to start? You already saw that today and now functions, but let's see the reference in our system. The reference date is January 1st. Okay, and if I do this, what it does, right? What is this number here? Okay, this one is 36,000. What it does? Let's see. as.Date. I'm going to transform this number. As you can see, this number 36,000 is going to add to the time. Okay, these one are 10 hours. Remember that 1 hour has 36 seconds. Then 36,000 should be 10 hours. Okay, that's what it does here. Right? There you go. And then if our reference date is here, of course, and 00, right? 0 hours. And then if we are adding these seconds, then we should have 10 hours later. That's what it does. Now here, let's see this number. This number is less than 36,000, right? However, look at this format here, 60 times 60 times 10. Okay, the first one, of course, is going to stand for seconds, minutes, and hours. And then here, what it's going to do as date. And also check out this time. I'm using time. So this function as date and as date time, they have different purposes. Okay, let's see. The first one is going to be for number, for day, of course. Let's see. It changed, of course, right? As you can see, it add 10 years and 5 days. Okay, it add 3,650 days to our calendar, or to our reference date in this case, right? And why it is not exactly 10 years? Because of course we have the years with 366 days. That's why it takes into account that, right? As you can see. Okay, that's important, right? Function as date and function as time. Okay, next step, extracting information. As we saw previously with using weekdays, month, and year. But let's see about transforming some strings and extracting information for these strings using some function from lubridate. Check this, that this function belongs to lubridate. Okay, so we change it. Check now that we had in the past the function ymd, but now we're adding hms, of course standing for hours, minutes, and seconds. My date, and my date is daytime. And then we have other functions. Hour, we already previously saw month and year. Now we can say hour, 12 hours, yes, indeed, it is hour. Minute, 35 minutes for our time. And month, of course, November, but is in this case 11. And how to say November? Okay, let's say label true. The same function month. However, I said label, yes, I want the label. As I said, November. Okay, November. It's important to see that this is a factor, right? November. mday, the function day, mday. Check where this function comes from. It's from lubridate. Okay, and yday, what it could be, right? What it could be, what wday, what it should be. What am I doing with this here? Remember that my date is November 5th. Then month, I mean my day, 5 days, right? That the y day, that means the number of the day of the year, and this function here is number of days in the month. Then this one has to be number of days in the year. Okay, and this one, wday, should be belonging to week. Okay, and here the function yd, the same, right? The same that function, that's the function we previously saw, weekday. In this case is wday, but belongs to lubridate. Okay, there are several functions for extracting information in a date variable. Okay, hour, minute, year, month, mday, year, wday. I personally have used this one, for example, yday, for comparing the beginning of some break in coronavirus cases, for example, to until the present day. Okay, counting numbers. Let's see, for example, this one. This is a vector, a string vector. Okay, but now we transform it. We say, I want this format, DMY. We previously saw YMD, MDY, and so on, but now let's see DMY. Because why? Because that first one stands for my day, second one is the month, and the third one is year. Let's see, date. Now we have some dates. It's a vector of dates. And now I say, okay, for all of this, we're going to subtract 1. Why? Because January 1st is going to be our day 0. Okay? How so? Or why so? Why day, as you can see, you will see, is X. It's counting, right? Carefully here, because as you can see, Y day, I use it for X, but X was a string, and I didn't give it the right format. So as you can see, it's telling us that the first date has 20 days after January 1st, but check here that I'm saying that it was the day, the month, so it should say 2. Okay, so carefully, that because we have, that's why we have to work with this format. It's important. Now, if I use Y date and I say date, the variable that I already transformed, the vector already transformed, so this one is in the right format that desired format, and as you can see, it changed, right? It changed now to 2. Why? Because I know it's January 2nd. You see, it's 2 days. However, X was not transformed to the right format. That's important. And also, as you can see here, this one is December 13, and it changed here. Okay, it's very important. We have to be very careful with this. Okay. Okay, let's see. Okay, if we want to say that January 1st is my important day, the day 0, so I should remove from date 1. How many days has passed, for example, from the first case, as I said, for example, the first coronavirus cases, and then January 1st is going to be counted as the first day, and 1 day after that is going to be January 2nd, but for saying 1 day after, we're going to say 1 minus 1. Okay, you see? And here, days. Let's see how many days after with the first case. Okay, 1 day, 50 days after, right? And so on. It's important to start counting when we are working in time series analysis. Okay, let's continue. Let's see now the data. Some spot. There are some different spots. So in the sun, and we want to see the different how many of them in each month. Let's see data some month. As you can see, there are several numbers here. Okay. As you can see, for example, it was around 58 sunspots in January for this year. If you see some decimal points here, it's because this was a interpolation. Okay, 70. Okay, and so on. But okay, let's see, for example, this. What is time? The function time. Okay, it's telling us. It is telling us. I want to extract information of all this information, but actually it's for the value for each cell. I cannot really extract this value here. It's telling, okay, for it's the same year, but 0 time after that, 0.083 time after this year, and so on. Okay, so how can I transform this to really extract the information from sunspot? Let's use it for this, a library zoo. Okay, and we're gonna convert all this information, so you can see here, to year and month. Okay, I'm really trying to extract. Remember that my whole goal is to extract each date from Sunspot. Let's see, using the function year-month, as you can see, you will see that this one belongs to the library zoo. Perfect. And then let's see what's the difference. As you can see, now I'm going to be capable of extracting the different dates for each cell. Okay, January 1749 and so on. Okay, what if I use the function as.Date? Let's see, let both combined. There it is. That one if we have to use the date too. Okay. Perfect. Now let's see using the function tstable. This one is like if I work with a library table, but this one is for time series. Okay. Let's see tstable. Let's see. Let's suppose we have this time series here. It's a sequence of values starting in this date, in January 1st, 2016, and finishing the last date of the year. And I'm gonna create a sequence by month. That means that how many information I will have, all the month of the year, but day. As you can see here, we have different dates, different days in different dates. Okay, let's see. Year week. This one is for working. As you can see where this function works, it's coming from. So tstable. Okay, it's important you can see that. This one is for counting how many weeks, or which one is that? Oh, the week of the year. Okay. So the first one, for example, that's different values. It's telling us, okay, our first date should be this one, of course, is this week. Well, however, I don't really think it is. Okay, right, check here is the week 53. Why is that so? Okay, how many weeks are in the year? We have 52 weeks, right? And why this one is saying the week 53? Because it's the finishing, okay, it's important. This one is the finishing week of 2015. Every week start on one Monday and finish in Sunday. Okay, that's why the first date of our month is saying that is the week 53. Okay, it's important. Now I understand why it's doing this. Okay, the next ones, okay, the week 5 of the year and so on. It's important, right, to know how this function works. Year month is gonna tell us the different month extracting from this vector x. As you can see, this tstable and zoo are not contradicting the library lubridate, but it's like a complement. Okay, you can see this libraries zoo and tstable as complements for lubridate. Okay, and let's see here. You can see that I can even work with both functions at the same time. Okay, here was the week of the year, and then I transform this to year month. Perfect. We have discussed so far different libraries to handle date as well, to transform or to extract values inside. Hope you like it.